Welcome to Holtz Academy's Rhino and Matrix tutorial. In this tutorial, I'll be showing some of the features and functionality we can see within Rhino and Matrix CAD software, and we talk about on the short courses and diplomas here at Holtz Academy. Today, what I'd like to talk about is one of the most frequently asked questions I deal with here at the Academy, from former students who used to use Matrix and are moving down to Rhino for whatever reason, or from people in the trade who are unable to purchase Rhino and are forced to downgrade what they've learned in a Matrix class in Rhino. And that is, how do I go about actually using some of the tools and techniques I've learned in Matrix in Rhino itself? The programs themselves are so similar in how they build their core solid models and core surfacing techniques that a lot of the advanced techniques are basically identical. But the basic workflow, because of all the builders Matrix has introduced and all the automated tools that Matrix has introduced, is actually quite different. So this is what tends to throw students the most, is how to actually, well, really where to begin. And that's why I built this tutorial. It's a tutorial specifically designed for former students of Matrix so they can downgrade their jewelry making knowledge and still work in Rhino just fine. In this tutorial, I hope to cover several different aspects of Matrix builders and how to do them manually in Rhino. I'll probably have to break this into two parts here. So the first part I will do will be replacements for the ring rail, how to control the grid snap in Rhino, how to go about making profile placer profiles in Rhino, and then how to use the gem loader and the bezel builder. In a subsequent tutorial, I'll cover some aspects of working with like the gem cutter and a replacement for the gem on surface. First, let's start with the ring rail and profile placer commands. In Matrix, we would find them in the black menu here, the last one on here, or we would find it in the tools menu here, the first one there. Either way, you're able to choose with the ring rail in Matrix here the nationality of what you're working with. Since we're in the United Kingdom, I'm using British, but American, Japanese, or what have you is available. And then we select the size and letter of the alphabet here and apply it. And that gives us a specifically set size ring circle of a given radius based upon standard measurements. And then we go to the profile placer, and I'm able to bring up this builder, and I'm able to take this ring circle and I'm able to apply it in here to be able to use dynamically placed ring profiles on a ring. And I can theoretically place as few or as many as I want, and I can adjust them freely. Now, this is probably one of the most powerful features in Matrix. Certainly is one of the most useful that I've ever seen that students take advantage of. And there's loads of different options for shapes and sizes we can use, and we can even create our own custom shapes. This is probably a big selling point for Matrix in and of itself. But doing this in Rhino, as it turns out, is in fact possible. It's just going to be a little bit slower. To do the same ring rail and profile placer in Rhino is certainly possible. It's just going to take a bit of more manual work on our part. So to start with, if we want to do a ring rail in the front view here, I would have to make a circle. Now, when you make a circle, you actually set a center point and you determine a radius or diameter in the command prompt. Now, the main thing is that we need to know exactly how big a size of diameter for our ring circle we need to make. So, what I might do, I've just escaped out, is I would actually go to the internet and I would look for any sort of online size converter. The one at onlineconversion.com/ring size is quite a good one. I can type in the same size of ring I was looking for in Matrix, and it would give me a diameter in millimeters, 16.51 in this case. Then I could go back here to Rhino, and I could make myself a ring circle starting from the center, and I could type in a diameter. Now, it's very important when you're actually making circles or making shapes with typed in coordinates in Rhino that you make sure that your mouse is in the work area or the viewport that you want to actually be working in. So if I was in the top view here and I typed in 16.1, it would make my circle in the top view. However, I want the circle to actually be upright, as would be the tradition for any sort of three-way diagram of a ring. So I'm making sure I'm working in the front view with my mouse before I type in 16.1 for my diameter ring size. And once again, if you inadvertently are working with radius, you can just click on this
option in the command prompt to switch between radius and diameter as needed. So that gives us a ring circle. The next order of business now is we need to get a profile on this. There's a little bit of a trick to this, actually, and once you learn this trick, this is a lot easier than it looks. It boils down to really just getting the shape perpendicular in the right viewport, right on the ring in the first place. And then once it's there, we can change its position accordingly around the circle. So I would go ahead and use the line from midpoint. Now this command here, the line from midpoint, is going to be very useful to us for building profile shapes in Rhino. With the help of the quad snap, I don't need project snap on or off, doesn't matter. I'm going to build a point right there from the 12 o'clock point of my ring circle initially. And then I can set the size of it manually. Now you'll notice that it's going to be at a little bit of an angle. This is because the size of my ring circle isn't perfectly precise. You also probably notice that it's snapping to full millimeter grid snaps. This can be a bit awkward. Now the first thing we will want to do before we actually continue on this is we'll want to fix the grid snap. So I'm going to escape out. And I'm going to go down and right click on grid snap and go to settings. Within settings, it'll go straight to the grid section. Now this is where I could control the size of the grid if I wanted to. That doesn't matter. If I change that to 50, for example, that's going to reduce the size of the total grid here. But more importantly, snap spacing is the one I want to worry about. So snap spacing, if I set this to 0.5, that means when I draw a line, with a line from midpoint now, from this top quad point, I can snap not only to the corners of every grid square, but also to the halfway points. This is the equivalent of the 0.5 millimeter grid snap spacing we have in Matrix. If I wanted to work with 0.25 grid snap spacing, I could do the same change again with grid snap. But for this case, this should be fine. So now I have the spacing the way I want it to. Now all I have to do to get this line straight is just hold down Shift. And that's going to turn on the orthographic snapping and keep it straight. And I can make this any size I want. I'll go for 6 mil wide here. So that's 3 mil in either direction with the line from midpoint. So that's giving me the bottom and baseline of my profile shape. Now for the top of the profile shape, I can pretty much draw whatever I want. I'll show you a complicated example on this one, and I'll show you a simpler example on the bottom. So I'll use a polyline command, draw from the end snap here, and I'll go up, give myself a corner here, and then I'll use the arc command, the arc start end point on arc command, to build a shape that covers the middle of that. Now I could do this in any order, because the next part is I'm going to take this last piece here, and I'm going to mirror it across the axis. And that will give me the left side and right side here. Now if you didn't line this up with the grid snap, this wouldn't be particularly accurate, so you'd probably want to use the end snap instead and draw it afterwards. And I could go outwards or inwards, it doesn't matter. Likewise, I can set the size of this to pretty much anything I want. Now the next important part here is I need to make sure that this shape is a closed shape. So that involves selecting it all and joining. And that will give me a single closed shape, and it will even say so in the command prompt. But that's the basics for building a profile. I could do the same thing on the other side if I wanted to. For example, I could actually use the same line from midpoint here, drawing from this point here, and going across. But this time I want to actually specify a certain distance. I want this bottom profile to be maybe 3.5 millimeters wide. So, because I'm only going halfway with this line from midpoint, I'm going to type in half of 3.5, or 1.75. Now typing that number and pressing enter in the command prompt constrains my distance. It restricts how long this line can actually be. So that's automatically set the width of this line for me. If I hold down Shift, it gets it straight, and now there's nowhere I can go. This white line is the difference between where my mouse is and where the point is. So just simply place the point. And there we have it, a 3.5 millimeter wide line. And then I can just use a dome with the arc here, or rather just make an arc dome here to get the rest of the remaining height of the shape. If I wanted to determine the height this way and constrain it, no problem, I could actually do it this way. I'll delete this. I'd make a line as a kind of dummy line to preserve the shape here. I go from this point here down, and I set the height to be 2.2. That's restricted the height of this line here, and now I can place that point anywhere I want. Now this line I'm not going to keep. It's just here to give me the measurement I need to be able to make my shape. And now I can use the arc command here from endpoint to endpoint, and then the middle is going to be up to that endpoint. Now that's guaranteed that the height of this is 2.2. I can now get rid of this vertical line. And this shape is now 3.5 by 2.2. Once I join it, I have a finished shape. And there it is. Now if I wanted to actually position these pieces, these cross sections rather, at an angle, it's actually easier than it looks. All I have to do is go to the front view and rotate them through the center. So my center of rotation is the center of the ring. And my first reference point is going to be right on that profile. And then I can position it at any angle I want. Maybe we'll try like 2 o'clock angle here. And I could get the same angle on the opposite side with a simple mirror command. Oh, wrong menu. There we are. Just right through the center axis once again. Oh, I missed it. Try again. Straight to the middle. And this gives us the 3 profiles we need for a one-rail sweep. We find the one-rail sweep in the surface menu here. Now, it doesn't have history on it, but in all honesty, we don't need it. We just need to make sure our seams are correctly located and lined up. That's going to be a big one here. One of the big differences between with and without history are these seam controls. Between this and this menu here, which really has all the same options we would have had in the command prompt with a one-rail sweep with history and matrix, only with a couple of extra additional ones that, in this case, we don't terribly need. I'm going to leave it open for the next part of this tutorial where I make the setting. But this gives us the basic ring here. Now the next order of business is to be able to take and make a setting for a gemstone. In Matrix, we would use the gem loader, and we could use then a round gemstone here of any size and shape we particularly wanted, say like a 5mm stone. And we would then go to the setting menu and we'd use the bezel builder. We'd apply the bezel to that setting. And it will make a preset shape which looks like it fits the stone. We can actually see inside the shape by turning off the preview shade. And this gives us some angle and control here. We can actually see the profile shape of the setting. And these has many different ways it can be controlled and many different options. And when you press enter, it has the F6 which lets it control it. Again, this is another very powerful feature in Matrix and very helpful for being able to build basic settings. But we can actually get by without it in Matrix, in Rhino as well. In order to make a gemstone in Rhino is actually just a simple matter of using the right command to build this shape. In this case, there's a couple ways we could do it. One way would be to use the polyline and revolve the shape. I'm going to set it on its own layer here to differentiate it. And you just have to make the shape of the stone itself. If you have the dimension of the stone, even better. And then we simply take that half cross-section shape there, that's sitting on the axis. The grid snap will help us here. And we use the revolve command to construct that shape as a solid. The full circle option will save us time. And that gives us the shape of this gemstone. It's not going to have facets as much, but for the sake of manufacturing, strictly speaking, we don't need facets. The bezel is going to be made the same exact way. It's one of those big ironies with Rhino that most of the commands you use to make the gemstone are the same commands you'd use to make its setting. So we just simply draw on yet another layer the shape of the setting itself with the same sort of principle of what we did before in Matrix. So we have the same sort of edging. Or if you genuinely can't be bothered to draw the shape like this, you could draw a simpler shape, which will look something like that. This is more like the traditional collets you see traditional bench jewelers making by hand and using with various types of cutting tools to be able to make a seat for the stone at the bench. This would work just as well as this, although I generally prefer this because it looks more professional. So again, take that shape and simply revolve it. Now I can almost hear everyone asking, well, what about stones that aren't round? As it happens, we can use a very similar command to do non-round stones called the rail revolve. Now the rail revolve works exactly like the revolve command, only it works by forcing the shape around an additional like shape-defining rail that could be anything other than round. So we could do like a square shape, we could do a rectangle, an octagon, an oval. I'm going to try it here on a rectangle just so you can see. So I'll turn off the default layer so I can see what I'm doing. And I will need the project snap-on this time. Otherwise, when I make my shape, I'll show you with the rectangle center corner, the shape might end up going three-dimensional. In this case, it doesn't. But it would definitely go three-dimensional on an ellipse. That angle right there is precisely the reason why we wouldn't bother doing this command without project snap-on. If I do the project snap-on, the shape works a lot better, as you can see. Keeps it flat on that particular grid. So I'll do the rectangle center corner, and I'm going to try and line up my rail here so that it passes inside both shapes. There it is. And then I'll move it so it sits inside both. Once we have that, we can then use a rail revolve on each shape individually. Rail revolve will be found in the same menu as the surface creation commands, such as sweep and revolve. As a matter of fact, rail revolve is actually a right click on the revolve command. So we just select profile curve, select rail curve, and our axle is going to be the same axle we use for the ordinary revolve. And that's going to give me a gemstone that's shaped like a rectangle. And now I do the same thing for the setting. Rail revolve, gemstone shaped like I grabbed revolve. So if you accidentally grab revolve, it will give you a circle, which isn't going to fit very well, as you can see. So I'm going to right-click on rail revolve this time and actually do it right. The rail may be hidden. If the rail's hard to see, you can actually take your stone and put it back into its original layer and even turn it off. You can do them isolated one by one. That might actually work better. Such as there. Now we have ourselves a working setting. Now, one side effect of the rail revolve is that the sides might get a bit wider if it gets too long than the other way. If this happens, we actually have another way of potentially building a gemstone in the setting, which it would involve the loft command. Another way of building a gemstone and setting would be to use some other basic surface creation commands. In this case, I've actually set this command up here to work instead of with a rail revolve, I would use a loft instead. So I have two curves for the top table of the stone, the girdle of the stone, and one for the queue, the bottom tip of the stone. And so these three shapes are going to be the basis for my loft command to be able to build this into a gemstone. I'll do this on the red layer. And you just need to make sure that your seams are in the correct location, just like at this wrist sweep. Now, the shape you're going to want to use of the style for loft here is going to be straight sections. And that will give you the nice basic geometry we would get, which would be very similar to what we would get from a revolve or rail revolve. The only difference is it's not going to stretch as much going in the long directions. And it will need to be capped, which is fine. It's easy enough to find. Cap command. Now, for the actual setting for this, we won't be able to we could actually potentially use the loft to do this, but it's going to be a very difficult way of doing it. I'm going to put the stone on its own layer, go to change object layer. Now you'll notice here to actually change layers in Rhino is going to be a bit more complicated than in Matrix, but it's easy enough to do. Just go to the layer menu and right click on it and go to change object layer. And then the light switch and locks work the same way as they always did. And now we have this curve here, which is the girdle we used for the loft here. I'm going to use that as a basis for a one rail sweep with this cross section. Now sometimes this will work, sometimes this will not. So the rail comes first, and the cross section comes next. And we give it a go. The most common reason why this would fail is it just doesn't like the sharp corners, in which case one way of getting around that would be to simply fillet out the sharp corners of every sharp corner on the girdle, and that should fix the problem with the sweep working. But in this case, we got lucky. Most of the time nowadays, it will get lucky, but every so often, maybe like 1 out of every 5 will just fail outright with this sweep. But if it does, it's an easy fix. Just fillet just soften up the rail so that it doesn't have these sharp corners. But this gives us a nice stone and setting, which is going to have a more consistently even wall. And this will work very effectively as a replacement for the bezel builder and the gem loader. For more information on GemVision Matrix or Rhino courses here at Holtz Academy, visit holtzacademy.com.